lecture, we have seen just the introduction to Solidity. I'll just take a quick overview and then we'll start with the new topic. So, Solidity is an object-oriented programming language. It's very similar to JavaScript. And then we have seen the difference between using memory and storage for the variables. Next, we have seen the basic layout of a Solidity smart contract, which starts with the Pragma Solidity version, and then write everything inside a contract. So the syntax it follows is contract, contract name, and then you inside the curly braces, you write the statements inside your contract. So up to this point, we have covered in the previous lecture. Also declaring the different data types. So the major data types that could be covered are unsigned integer, Boolean as a data type. Then we have address data type, which can hold 20 byte of Ethereum addresses. We have also a bytes data type and string data type. So this is what we have taken in the last lecture, along with what is an array and how to declare an array in Solidity. So today we are going to move forward with writing structures in Solidity. So look at this example first. So if you observe this example here, we are declaring a structure. So anything you write in Solidity is the first statement would be the Pragma directive, which tells which Solidity compiler version you're going to use. Next, you write everything inside a contract. So contract, contract name. So this voting contract, this is a user given name, and then you start the opening and closing curly braces, which defines the scope of the contract. So how to write structures in Solidity? You have to use the struct keyword followed by the structure name, and then you may declare all the members inside your structure. So here, if you see, I have declared 3 quint variables, 1 Boolean variable, 4 address type of variable. Then for counting votes, we have again taken unsigned integer. For height, we have taken unsigned integer. So structure is a way of grouping dissimilar items together. So if you want to group similar data types or similar elements, you use an array. Whereas in case of just back to the screen. Yes. So when you want to group together dissimilar items, you have to declare a structure. So there's a limit to how many elements can be present inside a structure. So structures can have up to 16 members. If the limit is exceeded more than 16 members, the result could be an error mentioning the stack is too deep. First, we are looking at the different types of user-defined data types that we can declare. So one more user-defined data type is mapping, which you are going to study it for the first time. So let's understand how to declare mapping. So mappings are declared as, this is the syntax. You use the keyword mapping, and then in the round brackets, you first mention the key type, then an arrow symbol, and then you mention the value type. So mapping is always between two data types, one mentioned as the key and one other mentioned as the value. So what can you declare as a key and a value type? So key type can be any data type except for a dynamically sized array, a contract, enumeration, or a structure. Other than this, it could be anything. Next is value type. So value type can be again any other data type, including mapping also. So you can declare a key type as any data type, and value type can be another mapping. So first, let's understand this with a simple example. So I've just pasted some code snippets here to understand the basic use case of these data types. So how do we declare a mapping? So this is an example. So you write mapping. In the bracket, you write key type, arrow, value type. So in this example, the key type is address and the value type is unsigned integer. So this is my mapping, and then you declare an access specifier. So I'm making my mapping public, which means it can be accessed throughout this contract and even outside of this contract. So mapping public, and this is balances. So balances is the name of the mapping that I have given. Next, we write functions like we write functions in our normal C++ codes. So the declaration of function is very similar to we used to do in C++. Follow the keyword function followed by any user given name. I have given the name of the function as update. In the bracket, you can pass an argument. So I'm passing new balance as an argument. So what I'll do, this new balance, which I've taken as a user input, I can pass this to balances. So what is balances? Balances is my mapping. Now we need to understand one more method that is written here, which is message.sender. So message.sender is basically a predefined method which directly fetches the value of an Ethereum address with which this contract is being called. So it will update the balance of this address. So just going back, this balances is a mapping from address to unsigned integer. So address is message.sender, which you are putting here. It automatically fetches the Ethereum address in use. The new balance is basically the value that you are passing from this function. Yes, people are. So we'll continue. So in this Solidity file, I have written two contracts. The first contract is the name is mapping example. The second contract name is mapping user. So in one Solidity file, I can even write two different contracts. Okay. Or you can write single contract in a Solidity file. There is no such restriction. So here in the first contract, that is mapping example, I have written a mapping which is address to unsigned integer. The name of the mapping is balances. So what is this balances going to store? With every Ethereum address, what is the balance associated? Okay. The next contract that I have created is mapping user. Right. So inside this, we have written one more function f, which is returning unsigned integer. Okay. So inside this function, what are we doing is I am creating a variable m of mapping example. What is mapping example here? If you go and observe, mapping example is the name of contract one, which is written inside the same file. So like we create object of a particular class, we can create variable of some other contract. So this is the syntax. So I've written the contract name, which is mapping example. Then a variable name m is equals to new mapping example. So this is a way of dynamically creating or dynamically allocating memory to this variable m. So with this variable m, what I can do, I can call the functions of contract one. Okay. So how can I call? Using the dot operator. So m dot update. So to this update function, what do I need to pass? Some uint value of balance. So I'm calling m dot update. In the bracket I have mentioned 100. So this would be given as an input to this function update, and the balance of this address would be updated. Here what I'm doing, I'm returning m dot balance is this. So this function f is going to just print the balance which is currently set. Okay. So we are going to do a hands-on, like I'm going to run this code on the Remix IDE and show you the output, how to give the input and everything. But before I go to the Remix IDE and show you the outputs, I have to just make you aware with the basic concepts and then we can move ahead. So is the idea of mapping clear, like how to declare a mapping? What do you mean by a key and a value type? How to use it in an example? Okay. So moving forward, how do we declare functions and modifiers in case of Solidity? So first is understand what is a function. So here I've written a function, say hello. It can return a string. So here I'm giving you examples of different types of function declarations. So the second example is a function multiply, in which I am passing two arguments. Okay, so these are just different variations of the function. So function multiply, I am passing two arguments a and b, and this function is returning the multiplication of these two values. So I'm passing two arguments, but the function is returning a single value. That is why a single uint is written here. Now we need to understand the access specifiers also. So we know that public and private, what is the access range. If I write a function as public, it can be accessible throughout the contract and even from outside the contract. Whereas if I write it as private, this function multiply could be called from the mentioned contract only. No outside contract can actually call the multiply function. Now we need to understand what is this keyword pure. Okay, returns means if a function is returning something, we write returns and in the bracket we mention what type it is returning. But coming to Solidity programming, when we write functions, there are two types of functions, either pure or view. So a pure functions means that it cannot actually modify the state variables, the blockchain state variable, whereas a view function can view it but could not modify. Pure function, neither it can view nor it can modify. So we are going to understand the difference between pure and view functions as we start doing our hands-on on the Remix IDE. But for the basic level understanding, it is important that we know that pure functions cannot read or modify the blockchain state variables. So now there can be a question like, what is a blockchain state variable? So blockchain state variable is basically which stores main information about the existing blockchain. For example, block.number is a blockchain state variable. Block.timestamp, what is the current timestamp of the blockchain? That's a blockchain state variable. So if you write a function as pure, it can neither read nor modify the blockchain state variable. It can only work upon the local variables which are declared here. Okay. Next is one more example. We have written a function increment, which is just taking two parameters x and y, and it is returning two parameters. So here you can see three different types of functions that we have written. The first say hello function, which is not accepting any argument, the bracket is empty, and it is returning a string. The second multiply function, which is taking two arguments and returning a single value. The third function increment, which is taking two values and returning two values. Okay. So all these versions are possible. So, but just one thing we need to remember is when a function is returning multiple values, we need to assign the values parallelly also. So, which means how should the function be called? For example, like this, x1 comma y1 is equals to increment 1 comma 2. So 1 comma 2 would be given to x and y, and the values which are actually getting incremented would be again returned to x1 and y1. So these are the simple ways in which we write different types of functions in Solidity. The basic syntax that is followed is keyword function followed by a user given function name. In the bracket, you pass the arguments, data type, variable name. Then you mention the access specifier, either public, private. Then you also declare the function type, whether it is a view function or a pure function. Then you write the return statement, whether the function is returning something or not. This is the basic syntax of writing functions in Solidity. Moving ahead, so as I just said that there are two types of functions that we can write in Solidity, either a pure function or a view function. So this is just a very small code snippet showing the difference between these two types of functions. So let's observe the first screenshot. So I've written a contract C inside which there's a function f taking a and b, and I've written it as a view function. Okay. So a function which is declared as view can read the state variables but cannot modify the state. Okay. So what am I returning from this function? A multiplied by some mathematical calculation like a multiplied by b plus 42 plus now. What is this now? Now is a blockchain state variable which gives the current time of the blockchain. Okay. So since I'm using it as a view function, it can read the state variable, it cannot modify. Whereas if you observe the second example in which I have written a pure function, I cannot actually read or modify the state of the blockchain. So here you can see I've just written the some mathematical calculations with local variables a and b. I cannot use plus now. If I write plus now or if I write plus block dot timestamp, this code is going to throw an error that the function is pure and it cannot read the blockchain state. Okay, so this is the major difference between pure and view function. So I think before going to the more examples, I should just help you with certain basics of the interface and how to run the code and everything. So let's go to the Remix IDE. Okay, so as I've shown a demonstration in the theory lecture. So this is the Remix ID. To start coding or writing your first smart contracts, you have to go to remix.ethereum.org. So Remix is the IDE which gives you the runtime environment where you can write your smart contracts. So once you go on to this link, you land up onto this page. So it has the entire documentation of how can you write your codes and like studying it from the scratch, but we'll directly go to this contract. Okay, so here you are going to write your code and you can just, if you just click on this, it will just show you the basic contracts. So by default, there are three contracts which are present in this folder, that is storage.sol, owner.sol and wallet.sol. So these are just dummy files which are present. For the Solidity files that we write, the extension is .sol. So if you want to write or create your own contract, you can just click on this, say create new file. Okay, and you can just start coding. Let me just do first.sol. So it gives me the space where I can start coding. So I have certain already created examples which I can just quickly show. Just give me a second. I'll just take quickly some examples. Okay, so we can just start with the basics. Here I've written. Let me just go to this interface and you can just start doing your coding. Right, so you just need to ensure that your Pragma Solidity versions are matching. Right. Once you do that, since I've taken it from a Word file, it is showing me some spacing warnings. That's okay. So I'm just showing you a dummy how to actually where to write your programs, how to compile and how to deploy them, and how to interact with a deployed contract. Okay. So looking at the first example, so this first statement is my Pragma directive telling me which version of Solidity I can use. Next is I'm writing the contract. So contract is a keyword followed by hello, which is the name of the contract. Then is the scope of the contract. I've declared only one variable of string type. The value is name. Next, I use a constructor. So we use constructor in the same way we used to write it in C++. So constructor is a special kind of method which automatically gets called when the contract is deployed. Inside this constructor, I am initializing the variable name to MIT. So once you're done writing it, you can go to the Solidity compiler and say compile. This is the name of my file, first.sol. So I'll compile that. So you can see there are two yellow marks which says that compilation successful with two warnings. So I can just ignore warnings as of now. And let's move to the deployment part. So for the deployment, you have to select an environment. So this we have discussed in the theory lecture that either you can do the deployment with a Remix VM or you can use a browser extension, which is your MetaMask. So let's do it with the Remix VM. You select any of the environments. I have selected Remix VM Osaka. And then for every associated environment, is a list of accounts which are associated. So what are these accounts? These accounts are Ethereum addresses, which is of 20 bytes. And since these are just dummy accounts, every account has 100 ETH, which is 100 ethers as a balance. We know that we need to pay a transaction fees or a gas fees in order to deploy the smart contract onto the network. So I've selected one of the accounts and then I'll click on this deploy. So once you say deploy, you see your contract name under the deployed contracts. Okay. So what you need to do is to go expand this, right? And then you can see the output. So here I have not done anything, like I've just used a constructor to initialize the variables. So I cannot see anything here. But as we take user input, as we display data, we are going to see outputs here. So one thing that we have seen in the last lecture was you use an address to deploy a smart contract that is called as the EOA. Whereas once the smart contract gets deployed, the contract gets its own address, which is the smart contract address. So let me just go to some other example. Okay. Okay, so let's take this code. Let me just replace this, remove this Solidity version I've already given before. Okay, so now with this example, I'm going to tell you about two important kinds of functions that we can write in Solidity. That is the setter and getter function. So the setter function is usually used to pass a value to a variable, whereas a getter function is used to display the value on the screen. Okay, so here I have declared a variable stored data of type unsigned integer. The first function set is taking an input x from the user and passing that value of x to stored data. And the get function is simply printing the value of stored data. So let's just run this code and understand. Let me just close this one, deploy again with some other address. Not necessarily you can deploy with the same address as well. So this is my simple storage contract. So what do we see in the output screen is whatever functions that you write, you can see here. So I've written two functions, set and get. That's why I can see both the function names there.